Hi, 8th graders. I'm back again. It's Mrs. Thompson, and we are continuing in 5.4. We're going to do example 3 today. We're actually going to focus on classifying systems. So we're going to learn some more vocabulary, and there's a lot more to remember. So I try to create a little chart here for you. So let me get to the very top of your page. Let's start up here. Consistent systems. Remember, we just learned in the last video and the video before, a consistent system is any system that has one solution or more than one solution. So that would be any of the systems we did in sections 5.1, 5.2, 5.3, all those had one solution because they crisscrossed at one point, okay? Or they could be like example 2, where it's a line graphed on top of itself, and so that would provide us with infinite solutions. So those are consistent systems. Now we can actually break it up into 2 subclasses. Consistent systems could be independent if they have exactly one solution, okay? Or they're dependent because they have infinite solutions. So the ones we did yesterday, I would say, yes, that was a consistent system, but it's dependent because of the number of solutions being infinite, okay? So systems are either consistent / independent, consistent / dependent, or they're just plain old inconsistent, okay? So here's a quick way to classify systems. If they have totally different slopes, that's the thing, 2 different slopes exist, then these lines are going to intersect at one point. They are going to crisscross at exactly one point, and so we would classify that as a consistent independent, CI. That's what we would classify it as, okay? Now, what if they have the same exact slope and the same exact Y-intercept? Well, you know what? That's the same line, so we have infinite solutions, and we would classify that as consistent dependent. That's a CD. But what if they have the same slope but different Y-intercepts? Well, those are parallel lines, which means we have no solution, and we would say, hey, that's an inconsistent system, okay? So this is truth right here. If you can remember what your possibilities are, I have one solution, hey, that means it's a CI. I have infinite solutions, that's going to be a CD. No solutions, that's just inconsistent, plain old I, okay? So that's the classification. Now you need that little bit of background there so we can get to the idea of how to classify systems, okay? So our directions are right here. Classify each system and give the number of solutions. So once we classify it, we can work backwards. If we figure out, hey, those are parallel lines, that means it's automatically inconsistent, then we would back up and go, hey, parallel lines don't crisscross, that means there's no solution. That's the number of solutions, okay? So the number of solutions, these are your 3 choices. There's either one point of intersection, whatever the name of that point is, there's no solution at all, or there are infinite solutions, okay? So when they are asking you, how many solutions are there? Those are your 3 choices, okay? If they're asking you to classify, then they're asking you, is it a CI because it crisscrosses at exactly one point? Is it a CD because it's the same line graphed on top of itself, or is it parallel lines which are inconsistent? So that's what we're looking for when we classify and then give the number of solutions, okay? Let me demonstrate A and B for you. A is not in any particular kind of form yet. It's almost slope-intercept form. We just need to divide everything by 2. Now the reason why I'm putting it in slope-intercept form is because that tells me some important piece of information. It tells me what the slope is, and it tells me what the Y-intercept is. Okay, that's important. I need to know that so I can make my comparison. Now let's see what this other one is. We've got -1/2 x plus y is equal to 1. So I'm going to get y by itself. I'm going to go ahead and add 1/2 x to each side. and I'm going to end up with y equals 1/2 x plus 1. So m is 1/2 and b is 1. Okay, so now I can actually do my comparisons. Well, what it looks like is I've got the same slope, same y-intercept, so these are the same lines. So that means it's going to be a consistent dependent system with infinite solutions. Okay, so if you get stuck, you get a little lost, look up at your chart here. Here's your chart, kind of your go-to information right here. Same slope, same y-intercept. That means it's same line. So here's my number of solutions. I have infinite solutions, and this is how I classify it, consistent dependent. And you don't have to write out the words consistent dependent. You can just write C, D. That's fine. That won't hurt my feelings. I'll know what you mean. Okay, so let's look at letter B. We have x plus 2y equals -4. Now, that is in standard form, and I'm going to go ahead and turn that into slope-intercept form. So I'm going to take away x, and then I've got 2y is equal to -x minus 4, and then divide everything by 2. Okay, so as it stands, it looks like I got -1/2 x minus 2, so m is -1/2 and b is -2. Okay. That's good. That's information I definitely need. Let's look at the other equation. I've got -2 times the quantity y plus 2 equals x. You could do this a couple of different ways. For you fancy folks that like to shortcuts, you don't have to distribute. You could just go ahead and divide each side by -2 like that, and then you'll have y plus 2 is equal to -1/2 x. And then just subtract 2 from each side, and you'll get y equals -1/2 x minus 2. And so as you're looking at that, do you see, whoop, I didn't mean to write that. Let's do m is -1/2, b is -2. Again, do you see what I'm seeing? Same slope, different y-intercepts. Are you seeing that? So how would I classify that? Well, I would say, like I did in the first one where we had the same slope, same y-intercept. I'd say that's a consistent dependent with infinite solutions. Just like that. Okay? So that was weird where they both were the same. That doesn't usually happen, but it did this time. So flip to the next page, and I've got some extra credit here for you. We're going to classify each system. I'm going to get you started, and I'm going to kind of help you set this up. The first equation's not quite in slope-intercept form. You need to distribute. So we've got -2x plus 2. So that means your slope is -2. Y-intercept is +2. And then for the second one, this one's very clear. Y is equal to -x plus 3. You've got slope is -1 and y-intercept is 3. Okay? Now what you're doing is you're assessing the slopes and the intercepts. Now, first thing I noticed right off the bat, we have two completely different slopes. So look back and see when the slopes are different, that means what? And so I need you to classify it. Okay, so is it CI, CD, I, or, and also in addition to that, number of solutions. I don't need to know what the solution is, I just need to know how many solutions they're gonna be. Okay, so you finish that part, and then I'm gonna leave B all to your device. You figure B out for extra credit, okay? So finish A, and then do B, and I'll check you tomorrow. Okay, so good luck with that. Please bring any questions you may have to class. Thanks a lot for listening.